So the paper on the topic for us is like life beyond distributed transaction and Apostate's opinion. So the paper writer Pat Halland has spent for his career on like analyzing these distributed transaction and the feasibility of distributed transactions, which includes like protocols such as 2PC and Paxos and various approaches to the quorum. So he has given 3 goals. One is discuss the scalable applications and think about the almost infinite scaling of applications, and the last one is like describe a few common patterns for scalable applications. So in the first one, discuss scalable applications. These scalable application will be designed by the persons or the designers or the developers who has already created some of the large systems, like who has already built these large systems can get the prototype or can have the ability to design for these scalable applications. So that's what he's saying about. And second one is like think about almost the infinite scaling of applications. So for example, you are building a large applications or one scalable applications for nearly some 30,000 or 40,000 network with the users. So and next you want to enhance that to like 50,000 plus or 60,000 70,000 networks on the people. So that should be easily scalable. What I'm saying is like 70,000 is an limit, but the scalable applications like should be enhanced to the infinity. So in that way, the large systems or scalable systems needs to be moduled or prototyped. And final thing is like a few common patterns for the scalable applications. So this is being the unnamed concept. It is hope like that we can agree for some consistent programmatic approach and a consistent understanding of the issues involved in the building scalable system. So what he's saying about like whatever the new concepts comes in and goes, but there should be some consistent programmatical approach, and also the consistent understanding of like how to solve the issue. So for the scalable applications, there will be like common issues and common goals. So that needs to be in the common programmatic approach and common problematic solving solutions. So that's what he's discussing about here. So next he is discussing about the assumptions. So there are 2 layers of the application under the scalable agnosticism. So in the lower layer of the application, like what happens is like it understands the fact that more computers get like added to make the system scalable. So like I explained in the previous point, there are more computers has been added to the scalable application where the system gets scaled. So it manages the mapping and also it manages the mapping of the upper layers code to the physical machines on the other locations. So what happens in the lower level code is like whatever the whenever like however the system gets scaled up, it should it should be like able to fix the problem and make the system run. And due to the scalability, it should not get slow, or it should not get any problem. It should keep continuing. So that's what he's saying about this lower layer. And the upper layer is like the application code is written without worrying about the scaling issues. So these 2 layers will have the same meaning, but it has the different perspective. So the upper layer of application code is like written like the code will be written like it doesn't depend upon the scalability. The code is already written and it will work whatever the whatever or however the level of the scalability goes. So we can write the application code that is not worried about the changes happening when the application is deployed against ever increasing load. So whatever the load however the load increases, the application deployed should be working and it should be happening. So the next assumption is scopes of transactional serializability. So like there are lots of research that has been going on this field, and like this includes 2PC, 2-phase commit, which can easily blocks when the nodes are become unavailable, and other protocols which do not block. So what happens like when we consider this situation is, and when we don't deal with and what happens when we don't deal with this, like when the real system developers and real systems as like we see them deployed today rarely even try to achieve or try to contribute to the transactional serializability across machines, or even if they do it, like it is with the like a very small number of tightly connected machines functioning as a cluster. So like in other way, we are not doing the transaction across machines except in the small simple cases where there is a tight cluster which looks like one machine. Instead, we assume this is a multiple disjoint scopes of transactional serializability, but which is really not the transactional serializability, but simply we assume that this is the transactional serializability. So the next is like most applications use the at least once messaging. So the best example is like TCP IP. So where we have the dilemma situations like which is the dilemma situation which is faced by the application developers, like to modify some data which is stored in the disk. So the scenarios is like the message is consumed but not yet acknowledged, else the database is updated and then the message is acknowledged. So in the failure condition, the system will be restarted and the message is processed again. So this dilemma, like in these scenarios, the dilemma arrives when the message delivery is not directly coupled to the update of the data, like other than the application, other than through the application actions. So while it is possible to couple the consumption of messages to the update to the durable data, this is not like commonly available. So the absence of this coupling leads to failure in the windows in which the message is delivered more than once. So the message plumbing does this because it's only the other resource is to occasionally lose messages, the at most once messaging, and that is even more rigorous to deal with that. So the next is like scalable applications use uniquely identified entities. So this paper will discuss about the upper layer code for each application, which must manipulate like a single collection of data, like which is calling as an entity, where the single collection of data will be called as an entity here. So there are no restrictions on the size of an entity, that is the collection of data, so except that it must live with a single scope of serializability, that is like with a one machine or the cluster. So the next is like atomic transactions cannot span entities. So we will argue and conclude that atomic transactions cannot span entities because the programmer must always stick to the data contained inside a single entity for each transactions. So this restriction is true for the entities within the same application and also for the entities with the different applications. So from the programmer's perspective, the uniquely identify entity is the scope of the serializability. So like it cannot be the spanned entities. So the next is like messages are addressed to be the entities. So most messaging systems do not consider the like partitioning key for the data, but instead it targets the queue which is then consumed by the stateless process. So there are a couple of things needs to be discussed here, which is already happening in the industry. So the first is like the size of the set of entities within the single application is growing larger than that can be fit in a single data store. And the second one is like the fetching and partitioning scheme is being separated into the lower layers of the application, and then it deliberately isolated from the upper layers of the application, which is responsible to store or stored in the business logic. The entity is like managed per partner state, which is meant to be the activities. So the sending data sends a message and which is addressed to the another entity. The sending entity is like as manifested by its durable state and identified by its entity's key. So the sending entity will send a message which is addressed to the another entity, which is like the partner state. So the next is the entity section. So here first we consider the guarantee of atomic transactions within a single entity. So the next is like the subdivision of that is like disjoint scopes of serializability. So here the each entity is defined as a collection of data with a unique key known to live within a single scope of serializability. So it is the aspect that warrants giving the entity a different name than an object. So object may or may not share the transactional scopes. Entities never share transactional scope because repartitioning may put them on different missions. So the next is uniquely keyed entities. So these are the code for the upper layer of an application and is naturally designed around collections of data with each will have its own unique key. So they are used as a keys to locate the data implementing between the applications, and this is the natural paradigm like where we observe the boundary of the disjoint scope of serializability is always identified by the unique key in the real world. So the next is like repartitioning and entities. So like in the emerging upper layer is scale agnostic, and the lower level layer decides how the deployment evolves as requirements for the scalability change. So entities are spread across scopes of serializability using either hashing or key range partitioning. So yeah, that's what as we said, like the lower level lower level decides like the how the deployment evolves for the scalable change, and the upper layer is for the scale agnostic. And the next is atomic transactions and entities. In the scalable systems, like we cannot assume the transactions is for through updates or across these different entities. Each entity has a unique key, and each entity is easily placed into one of the scope of scalability. So put more simply, the lower layer of the application will ensure each entity key reside on a single machine, and different entities may be anywhere. So the understanding of the existence of the entity as a programmatic abstraction, the use of the entity key is the clear commitment to assume a lack of atomicity across entities are essential to provide a scale agnostic upper layer to the applications. So what happens is like large scale applications that we use in the industry today, we just don't have the name for the concept. But from an programmatic view, from an upper layers perspective, it must assume that the entity is the scope of the serializability. Assuming more will break when the deployment changes. So the next is like messaging across entities. So we will like discuss or elaborate like how we communicate between the entities. So messages to communicate across entities is like if you can't update the data across two entities in the same transactions, you need a mechanism to update the data in different transactions. So the connection between entities is via a message. So the next is asynchronous with respect to sending transactions. Since messages are across the entities, the data associated with the decision to send the message is in one entity, and the destination of the message is in the other entity, because the message is communicated from one entity to the other entity. By the definition of an entity, we must assume that they cannot be automatically updated, which is like atomically updated. Next is the naming the destination of the message. So in the programmatical approach, the application has one entity wants to send the message to other entity. So the location of the destination entity is not known to the scale agnostic code. So the next is repartition and the message delivery. So when the agnostic part of the application sends a message, the lower level scale aware portion hunts down the destination and delivers the message at least once. So the next we will discuss about the entities as way and objects. So this section gives the idea about the object orientation and the service orientation. So we will see about the entities and the object instances. So there are two important clarifications that must be made to consider an object that to be an entity. So first, the data encapsulated by the object must be strictly disjoint from all other data. So the next is the second one, that disjoint data may never be automatically updated with any other data. So the next is message versus methods. So method calls are typically synchronous with respect to the calling thread. They are also synchronous with respect to the calling object's transactions. So while the called object may or may not be atomically coupled with the calling object, the typical method call does not atomically record the intent to invoke a message and guarantee at least once invocation of the called message. So the next is entity and the service oriented architecture. Everything discussed here is supportive of the SOA, service oriented architecture. So the most SEO implementation embraces independent transaction that has the scope across the services, not only within the service but also across the services. So next we are seeing about the activities coping with messy messages. So in this section we will have the notion of an activity, which is the local information that needed to manage a relationship with the partner entity, that is the other entity where the messages will be sent and will be stored in the next entity. So in that we have the features like retrieve and idempotence. Since any message ever sent may be delivered multiple times, so we need in the applications to cope with repeated messages. So while it is possible to build the lower level support for the elimination of duplicate messages in an almost infinite scaling environment, the lower level support would need to know about the entities. So the knowledge of which the messages have been delivered to the entity must travel with the entity when it moves due to the repartitioning. It should not move away from the entity, it should travel within the entity. So next, the defining idempotence of substantive. So in this behavior, processing of a message is idempotent if a subsequent execution of a processing does not perform a substantive change to the entity. So natural idempotence is to accomplish idempotence. It is essential that the message does not cause substantive side effects. So the next is remembering messages state, which is to ensure the idempotent processing of messages that are not naturally idempotent, but that the entity must remember that they have been processed earlier. So this the defining this knowledge is called a state here. So the next activity is coping with the messy messages. So here the activity is managing state for each partner, to track the relationship on the messages received. So the it keeps tracking about the relationship on the messages received. Each entity within the scale the applications must somehow remember the state information about its partner. That is each entity should remember about the information about its partner entity. So it must capture the state on a partner by partner basis. Let's name the state an activity. So each entity may have many activities if it interacts with many other entities. So activities track the interaction with each partner. So whenever it keeps relationship with the other partner, it tracks the information that gathered between these two entities. To ensuring at most once acceptance via activities processing messages that are not naturally idempotent requires ensuring each message is processed at most once. So that is the substantial impact of the message must happen at most once. To do this, there must be some unique characteristics of the message that is remembered to ensure that it will not be processed more than once. So the naturally idempotent requires the each message is processed at most once. So to do this, we are having the condition there must be unique characteristics of the message. So that will be processed not more than once at a time. So the problem on coping without atomicity is the uncertainty at a distance with the absence of some distributed transaction means we must accept some uncertainty as we attempt to come to decisions across different entities. There will not be entities at almost everywhere, so we must accept some uncertainty as we need to make some decisions across different entities. So it is unavoidable that decisions across distributed systems involve accepting uncertainty for a while. So to follow up the other activities and the management of the uncertainty, entities sometimes accept uncertainty as they interact with each other entities. Like we before said, it has to accept the uncertainty, and this uncertainty must be managed on a partner by partner basis, and one can visualize that as being revealed in the activity state for the partner. So in the same coping without atomicity, the tentative operations confirmation and cancellation essential to the other tentative operation is the right to cancel, and sometimes the entity that requested the tentative operation decides whether if it is not going to proceed further or not. On further researching, we understand that uncertainty and almost infinite scaling, or the interesting aspect of this for scaling, is the observation that the management of uncertainty usually revolves around two-party agreements. It is frequently happened the case that the multiple two-party agreement is happening. Still, there are knit together as a web of fine-grained two-party agreements using entity key as the links and activities to track the known state of a distant partner, which is the other entity partner. So after elaborating those goals and activities, we come to the conclusion that one emerging trend is for an application to scale to its own size that do not fit onto a single machine or tightly coupled is for the set of machines. So we have keep seeing that specific solutions for a single application emerges first, and then the general patterns are observed, so which is some programmatical approaches. So based upon these general patterns, new facilities are built, empowering easier construction for the further business logics. So today we see some new design pressures foisted onto the programmers that simply want to solve some business problems, and also those developers will have the programmatic approach to solve the further scalable applications in the common way. So, but unfortunately, programmers striving to solve business goals like e-commerce, supply chain management, financial and healthcare applications is keep increasing, and they need to think about scaling without distributed transactions. So finally, in this paper, we have introduced and named a couple of formalisms terms emerging in large-scale applications. Like entities are a collection of named data which may be atomically updated within the entity but never atomically updated cross entities. So activities comprising the collection of state within the entities used to manage messaging relationships with a single partner entity. Thanks for the opportunity.